All right, friends, we're going to be looking at our lesson 2.13, which is about bracelet budgets. So on the warm up, you can click the beads to place them on the bracelet, and then you're going to hit make it when you're done. So you're just going to take some time making a little bracelet that fits what you like. When you're done, you'll hit make it. And you can just do a little description about your bracelet design, tell me what you like, how you made it, and then go ahead to slide 2. So it says, here are two types of beads. We have the black beads that are 50 cents each, and the basketball beads that are $1 each. And it wants us to make a $5 bracelet. So that was 50 cents. There's $1, $2, $3, $4, $5. Yours might look a little different. Maybe there's 5 basketballs. Maybe it's all black beads. But you should get to $5 for your bracelet here. If you need to make a change, hit make a change, and you can just get rid of any of the beads. And again, maybe it was just 5 basketballs because they're each $1. There we go. That's a bracelet that costs $5. So there's many options here, just thinking about what are the ways we can add to $5. Let's look at slide 3. It says each of these points represents a $5 bracelet. X is the number of black beads, Y is the number of basketball beads. Which equations represents this bracelet? So we see our y-intercept here is at 5, right? Which tells us one bead you can, or one bracelet that you can make has 5 basketball beads and 0 of the black beads. And then if we look at the slope, as it goes down 1, it shifts over 2. So we're going down 1 over 2 to get to each next option. So our slope is a negative 1/2, which we can write as negative 0.5. So if we were to write this as an equation in our y equals mx plus b form, we would have y equals negative 0.5x plus 5. And this is one way we can write this equation. We don't see this option because this has a positive slope, which is wrong. It's definitely negative. If we take this equation and subtract 0.5x from each side, it right there is in standard form, but if we subtract 0.5x from each side, we get y equals that negative 0.5x plus 5, which is exactly what we were looking for. So you can explain your thinking of how we found the slope and the y-intercept and use that knowledge to make that equation. When you're all set, push ahead to the next slide, just slide 4. Binta's bracelets. Binta can spend $5 or less on a bracelet. Make some bracelets that Binta could buy. So this would be $1. That would work. Or what if we put 2 basketballs? That would work. 3 basketballs, 4 basketballs. All of those options would work and are less than $5. We could do some of these black beads. That gets us to $2.50. So we could add a basketball, just kind of seeing all the different options that are less than $5. Just making a bunch of points, and you see all these points are getting shaded in. Good. Voila. Beautiful. We should be making a bunch of points. We're going to notice that all these points in this shaded area are going to be options that we could use. So points that are solutions, as we can see, become these red dots. If I were to put something on the graph that is more than $5, it'll be black like so, because it is not a solution. And go to the next slide when you're all set. Here are everyone's points from the previous screens. Click a point to see the price of the bracelet. So if you click a point, it tells you how much that bracelet cost. What do you notice and what do you wonder? Take a second, look at some of these prices, and think about what you notice and what you wonder. Okay. Maybe you notice that all the bracelets below that line are less than $5, right? Maybe you notice that all the bracelets on the line are exactly $5, and any of the ones above the line are more than $5. You may wonder which bracelet will be made, what the biggest bracelet that they can make, any other wonderings you got here, and then push ahead to the next slide. Binta can spend $5 or less on a bracelet. X is the number of black beads, Y is the number of $1 beads that are the basketball. Which statement describes all the bracelets that Binta can buy? So we do X is the 50 cents. So we do 0.5 times X. That's how much money we'll be spending on the 50 cents. And that's going to be added to 1 times Y for how much money is spent on those $1 beads. And we want that to be less than or equal to 5. It can be exactly equal to $5. That would work. Or it can be less than, because it tells us at the top that Binta can spend $5 or less. Beautiful. Explain your thinking, how that makes sense, and then go to slide 7, where we're talking about Caleb's bracelet. So Caleb is looking at the rainbow bead, which is 25 cents each, and the ice cream bead, which is 75 cents. So Caleb loves Binta's bracelet and wants to make his own. This inequality here represents all the bracelets that he can make. So what do these numbers represent? So we see this is adding up the price of all of the rainbow buttons, and this is getting the price of all the ice cream buttons. And when you add them together, it can be greater than or equal to 6. So Caleb can spend $6 or more. Caleb is open to spending more than $6 as well on a bracelet. Beautiful. Slide 8 when you're ready. Each of these points is a solution to 0.25x plus 0.75y greater than or equal to 6. Click several points to see what this means. So this point here is saying there's 9 25-cent beads, 10 75-cent beads, and that gets us to a $9.75 bracelet. Here's another point. And as we click around, you'll notice it breaks down and plugs in the X and the Y values to get our total cost of the bracelet. And it says, in your own words, what is a solution to an inequality with two variables? So what are we noticing? What makes it a solution? Why are all of these solutions to this inequality? Think about that response there. Notice that we took the X and the Y values to prove it's a solution, right? When we plug these X and Y values in, we're getting a true inequality, making it a solution at those particular points. Let's go to slide 9, and feel free to pause at any point. Slide 9 said, is 2 comma 10 a solution to this inequality? You can use blank paper to help with your thinking. So 2 comma 10 would be this point here, right? Where x is 2, y is 10. It looks like it's near other points, so it's probably a solution, but let's plug it in to make sure. So in 2 comma 10, our x is 2 and our y is 10. So we have 0.25x, so 0.25 times 2 plus 0.75 times 10 greater than or equal to 6. 0.25 times 2 is 0.50 plus 0.75 times 10 is 7.5. When you add 7.5 to 0.5, you get 7.75. And yes, that is greater than or equal to 6. It's bigger than, so it is a solution, right? Because we got a true statement, and it is a price that is larger than the $6. So that would fit the criteria that Caleb was looking for. Explain your thinking there, or show your work, and then push ahead to the next slide. This is a compare and contrast. It says, here's how 2 students determined 2 comma 10 is a solution to that inequality. Discuss each person's strategy with a partner. So Marco did their first strategy by taking this inequality and graphing it. Notice it has a y-intercept and slope, and it graphed the line. And then when Marco looked at that point, 2 comma 10, they noticed it's above our boundary line, so it's in the section where our solutions are going to be. So that works. Like, we can graph and see if the point is in the correct section. That's an awesome method. It can always work. Jada did what we did on the first slide and took that 2 comma 10 point and plugged in 2 for x and 10 for y and solved to verify that, yeah, 8 is greater than 6, so it will work for this inequality. Either method is perfect. Some people like the visual graph, some people like algebra working it out. I want you to feel comfortable with both, but it's definitely normal if you have a favorite or if your brain is particularly drawn to one version. Okay. Slide 11 says the graph here shows some solutions to 0.25x plus 0.75y greater than or equal to 6. Select all the other points that are solutions. So we could graph these points. So 14 comma 8 is about here. 13 comma 1 is here. 7 comma 5 is here, and then we have 1 comma 13 right there, and then finally we have 0 comma 8. So I would say that the yellow and the blue are definitely solutions. They're around all types of other solutions. The other 3 I'm not sure about. I don't know where the exact line is, so I would recommend plugging these in to a calculator. So for the first one, we have 0.25 times our x value, which is 13, plus 0.75 times 1. And we're wondering if that's greater than or equal to 6. So it was 0.25 times 13 plus 0.75 times 1, which gets us 4. So yes, that one does work. Greater than or equal to? Did I do that right? 0.25 times x, which is 13, plus 0.75 times 1 is greater than or equal to 6. Oh, we got 4. That's why. 4 is not greater than or equal to 6, so that does not work. Come back and let's finish this out in part 2, and I'll see you then.